Hello everyone, I welcome you all to my channel Revealing Concepts. Today we are going to learn a new topic in math, that is about the irrational numbers. Our agenda for today would be learning the definition of irrational numbers, the irrational number theorem. Also we will see the application part of it. We are actually going to use this irrational number theorem to prove certain postulates in mathematics, and then we are also going to see the real life application of it. So let's start with the class. The first part is knowing about the definition of an irrational number. Before moving on to the definition, I would want to brief you about the number system that exists. We all know that the set of numbers, right, from 1, 2, 3 and so on is nothing but the natural numbers. Then when we include 0 to this set, that is 0, 1, 2 and 3, this set is called as the whole number set. Then if we include the negative integers and the positive integers, that is from 0 towards the left side, minus 1, minus 2, minus 1, 0, 1, 2, 3 and so on. So this is the set of integers. Then the numbers of the form p by q, where your q is a non-zero number. This type of numbers are called as the rational numbers. So we have the natural number set, we have the whole number set, the set of integers, and then we also have the rational number set. So today we are going to learn about irrational numbers. Let us actually understand the definition of irrational numbers using the concept of rational numbers. Here if you see, the definition says a number x is called as an irrational number if it cannot be written as p upon q, where q is not equal to 0 and p and q are integers which are co-prime in nature. Now what does this mean? That if there is a number, let's say any number, which cannot be represented in the form of a simple fraction, right, of the form p by q, such that your denominator is not equal to 0, it has to be a non-zero integer. Both these are integers and they have to be co-prime. Now what do you mean by co-prime? Co-prime means two numbers who don't have anything as their common factor. So their HCF in this case would be nothing except for 1. So 1 is the only common factor between those two numbers. So I hope you are thorough with the definition of an irrational number. When you come across, when we try to understand irrational numbers with the help of examples, so root 3 is a number, root 5, then the number pi, and such decimal numbers whose representation is very distinct. It is never ending and non-repeating also. For example, the decimal representation of pi, that is 3.14, and then we have numbers ahead of 14 also, the digits ahead of 14 also. Now those digits, they are first of all non-repeating and at the same time they are non-ending also. So any number which is represented in this form, so we have root in it, then any number which is non-ending and it's non-repeating also, such numbers are called as the irrational numbers. So these are few examples of irrational numbers. As of now, I would want you all to ignore this part because we are coming to this part later. Let's start with the irrational number theorem. What is the statement of this theorem? It says that let p be a prime number. So we take p as a prime number. Now why did I write p later? Because I want to exclusively divert your attention toward, exclusively draw your attention towards it. You need to keep in mind that p is a prime number. Now if P divides A square, then you are supposed to prove that P divides A, where A is a positive integer. So here you are actually given two numbers, one is a prime number, one is normal positive integer. You have been given that if your P is dividing A square, then P would also divide A. How you are going to prove this? So let's start. We are first going to write the prime factorization for the number A. We don't know whether the number is a prime number or a composite number. We have just taken it to be a positive integer. That is why we are writing its prime factorization as P1, P2 and so on. P1 into P2 and so on multiplied by Pn. Now what are these Pi's that I am taking, that is P1, P2 and Pn? These are nothing but the prime numbers and the prime factors of A, because we are writing it as the prime factorization of A. Now when I square both the sides of this equation, so I get A square equals to P1 into P2 and so on up till Pn the whole square. So when I distribute the squares to each term, since it's in multiplication, so A square would be equal to P1 square multiplied by P2 square and so on up till Pn square. So what I have done is I have named this equation as 1 and I have named this equation as 2. Now keep these two equations aside. Now we know that P divides A square. This is something that we already know. If P is dividing A square, it means that P is a factor of A square. When I say that 2 is dividing 6, it means that 2 is a factor of 6, because you can write 6 as 2 into 3. So 2 and 3, these are the factors of 6. So if P is dividing A square, it means that P is a factor of A square. But what do we know about P? We know that P is a prime number. So P becomes a prime factor of A square. So if P becomes prime factor of A square, and we already know that the prime factorization for A square is this, wherein Pi's are nothing but the prime factors of A square, it means that your P, which is a prime factor of A square, has to be one of these Pi's. So P is supposed to be one of these Pi's. It means that P is a prime factor of A also. Now why do I say that P is a prime factor of A? Because all these are the prime factors of A as well. So that is why finally you can say that P is divisible. I'm so sorry, P divides A, or A is divisible by P. So I hope you understood the proof of it. Now here if you see, I forgot to mention that how do I conclude that P is a prime factor of A square? Of course, this is by the fundamental theorem of arithmetic, which we have learned in the last class. So any number which can be expressed as product of primes, those prime numbers are nothing but the prime factors of that particular composite number. So here if you express P as P1, P2 and so on up till Pn, so of course these becomes the prime factors of P. So this is the irrational number theorem. Now let's move on to actually proving whether root 2 is irrational or not. Meaning you just have to prove. Okay, so now let's move on and prove that root 2 is an irrational number. Now before moving on to the proof of root 2, I would also want to mention an important technique of solving this kind of proof. This is a standard or a general template that you all must refer to whenever you are solving proofs of this kind. Meaning whenever the question is proof that something is irrational, follow this template only. So these are the steps that you need to follow. We are going to use a technique in order to prove that root 2 is irrational, and that technique is called as proof by contradiction. Now what do you mean by contradiction? Something which is not right, something that's incorrect, something that's absurd. So there are 4 small steps which you need to follow. The first step is you have to assume the opposite of what is asked. You will actually able to understand when I solve the proof. So you are supposed to assume the opposite of what is asked. Then you have to derive the consequences. Meaning, once you assume the opposite of what is asked, based on your assumption, you have to actually derive certain steps, you have to derive certain conclusions using logical steps. Now, this something that you are deriving is basically impossible or absurd, right? When you will actually solve it, and you will see that you actually come up to something that is not acceptable, that is not correct. So that is why we say that you derive the consequences of the opposite thing that you have assumed, and you find a contradiction, you find something which is weird, which is absurd, which is incorrect, which is not true, and then you conclude that whatever assumption you had made pehle, that leads to a contradiction. That is why your assumption is wrong, and hence the initial thing is correct. Now, this might seem to be a little abstract to you, but we are going to use these steps in proving root 2 is irrational. So, let's start. We are supposed to prove that root 2 is irrational. According to step 1, we are going to assume the opposite of what is asked. We are asked to prove root 2 is irrational. What is the opposite of it? Root 2 is rational. So we are going to assume that root 2 is rational. Now, if root 2 is rational, then what is the general representation of a rational number? It can be expressed in the form of P by Q. So this implies that root 2 is equal to P by Q. Now this is a very, very important step. You need to mention this where Q is non-zero and P comma Q are co-prime numbers. Very important. So since you have assumed that root 2 is rational, now you are deriving the consequences of it. So the consequence of a number being rational is that it can be expressed in the form P by Q, where Q is the non-zero number and P and Q both are co-prime numbers, meaning the only common factor between them is 1 and nothing else. So we have got root 2 as P upon Q. Now we are going to use various logical steps and we are going to come up with something that is impossible and absurd. We have started with the step number 2. So now we are going to square both the sides. Squaring both sides. We get root 2 square equals to P by Q the whole square. So this implies you get 2 equals to P square upon Q square. So which is, when you shift Q square over here, you get 2Q square equals to P square. So what did we get? We get 2Q square equals to P square. Now here if you see, your P square is expressed in terms of 2 into Q square. So if you want to just understand it in more simplified manner, what I can conclude from this theorem, this statement, what is something that you can conclude? Let's say that if you shift 2 over here, so that is going to divide your P square. So can we say this implies that your 2 divides P square. Now, keep in mind, 2 is a prime number. And as per the irrational number theorem, if 2 or any prime number divides a number ka square, then that prime number divides the number also. So if 2 is dividing P square, then this implies that your 2 is going to divide P also. This is by irrational number theorem. It is advised not to use any kind of shortcuts while writing answers in your paper. So if 2 is going to divide P square, then by irrational number theorem, your 2 divides P as well. Now keep this as equation number 1. If your 2 divides p. 2 is dividing p, right? So can you say that your p can be written as 2 into r, right? If 2 is dividing p, it means that 2 is a factor of p. It means that p can be written as 2 into r. Now, this is your equation number 2, right? What you do is name this as equation number A. Put 2 in equation number A. So wherever there is p, you put it as 2 into r. Okay, so 2 into q square equals to 2 into r the whole square. So that is 2 into q square. We have 4 into r square. 2 ones are 2, 2 twos are 4. This implies that q square is nothing but 2 into r square. So now what did you get? You get that q square equals to 2 into r square. This is same like this arrangement where your p square was 2 into q square. So what can you conclude from this using this theorem of irrational number, the irrational number theorem? It means this implies that your 2 divides q square, which implies your 2 divides q, right? Now, if 2 divides p, it means that 2 is a factor of p. If 2 divides q, it means that 2 is a factor of q. So 2 is a factor of p, 2 is a factor of q as well. This implies that 2 is a common factor of p and q. But students, is this possible? It is not possible. Why it is not possible? Because we know that p and q are co-prime numbers, and co-prime numbers do not have any common factors except for the number 1. So here if you see, we tried deriving the consequence, and what did we get in return? The contradiction that we got is that this is a contradiction as p and q are co-prime numbers. Now, if this is a contradiction, we have arrived to a contradiction. We are going to conclude that our assumption was wrong. Why did we get this? Because we have assumed something that is wrong. Hence, this implies our assumption is wrong. Hence, root 2 is rational number. So once again, we started with step number 1, that is with a wrong, or to be very precise, the opposite assumption of whatever is given, right? Then all the steps, this is nothing but the logical steps that have been followed after the assumption. So that leads us to the consequence. So this comes under step number 2, okay, that is deriving the consequence. And once we finish with step number 2, we come to step number 3, which is basically the contradiction part of it. What is the contradiction? That we get a common factor of p and q, but that is not possible because p and q both are co-prime numbers. And finally, we conclude. So this is your step number 4, in which we conclude that our assumption was wrong, and hence root 2 is an irrational number only. So the application of irrational numbers can be actually in the area of geometry and engineering. So how it is? It is used in geometry and engineering. So how is it actually used? So if you as an engineer, let's say a civil engineer, wants to construct a pipe which is circular. Now if you want to find out the length of the circular pipe, how? I'll tell you, the edge length. Meaning, let's say this is the pipe, and if you want to find out the edge length of this, right, which is also called as the circumference. We want the edge length of the circular part. We want to find out like exactly how much, sheet we need in terms of length to actually make this pipe. So the edge length of the circular part, we can say. So we all know the formula for circumference. It is 2 pi r, where 2r is nothing but the diameter, so it can be written as pi into the diameter. Now if it is given that the diameter of this pipe is 1 meter, then we know that the circumference or the edge length for this particular pipe would be 3.14 meters approximately. So this is how you can get the edge length of the pipe for construction. Similarly, if you want to make a lid for this, so you have the formula for area, and area is 2 pi r square. So if you know the radius of this particular lead, then of course you just have to multiply. So if diameter is 1 meter, then in this case it has to be 3.14 into 0.5 meters. The answer would be whatever is the answer, that is nothing but the area of the cylindrical top. The top of the cylinder. So students, with this we come to the end of today's lecture. In today's class, we studied about the definition of irrational numbers. We studied about the irrational number theorem. We saw how to prove that the numbers are, let's say that root 2 is irrational using the irrational number theorem, and finally we also saw its real life applications. I would request you all to pause the video and actually note down these steps so that it would be useful for you to solve problems of this type. So thank you everyone for watching the video. See you again in the next video.